Assalamu alaikum. Welcome to the lecture 9 of Unit First. Today's topic is thyristor protection. Firstly, we should know why protection of SCR is needed. SCR is a very delicate semiconductor device, so we have to use it in its specified ratings to get desired output. SCR faces different types of threats during its operation due to overvoltage and overcurrents. There may be false triggering of SCR due to high value of dV by dt. Also, the high di by dt results in the local hotspots in SCR which causes damage to the SCR. So, in order to avoid such threats, we should use thyristor protection schemes. There are different types of thyristor protection schemes available for satisfactory operation of SCR. Protection of a semiconductor device or a thyristor is an important aspect for its reliable and efficient operation. To avoid these transients that cause either maloperation of the circuit by unwanted turning on of SCR or permanent damage to the device due to reverse breakdown, we are adopting many protection schemes. The various schemes adopted for the protection of SCRs include overvoltage protection scheme, overcurrent protection scheme, high DI by dt protection scheme, high dV by dt protection scheme. So we are first studying what's over voltage, what's over voltage protection, what's over current protection, what's high di by dt protection, what's high dv by dt protection. We are also studying snubber circuit, crowbar circuit that's used for SCR protection, and simultaneously we are studying the protective measures that we are using to prevent against such over voltage, such over currents, such a high rate of rise of current, high rate of rise of voltage. Now, what is the over voltage protection? A thyristor may be subjected to internal or external over voltage. Internal over voltage, as already explained during turning off of SCR, this high voltage across the terminals is due to this high di by dt during the turning off of SCR. If the di by dt is large, this voltage will be large and it may exceed the rated breakover voltage, and thus our device may get damaged. That's why we need protection against such over voltage. External over voltage. These are caused due to interruption of current flow in an inductive circuit, or due to lightning strokes, or when a thyristor converter system is fed through a transformer. Whenever these transformer is energized or de-energized, results in the over voltage. And this results in the over voltage, and this may cause turning on of a thyristor. These over voltages may appear across the load, causing the flow of large flow currents. These over voltage causes different types of problems in thyristor operations, like increase in the leakage current, permanent breakdown of junctions, unwanted turn off of device. So we have to suppress, or we have to remove such over voltage, or we need protection against such over voltage, against the internal over voltage, also against these external over voltage. And for protection against these over voltage, we are using this highlighted part, that is this we are using varistors. That means non-linear. We are seeing these varistors or voltage clamping device, and in this voltage clamping device we are using in majority times the mostly used voltage clamping device is metal oxide varistor. This is basically a non-linear resistor. These non-linear devices or voltage clamping devices are connected in parallel to that switch to whom we have to give the protection, that is this SCR. That means this varistor is connected in parallel with this SCR. This inductor or this combination of this circuit breaker and fuse, and this is basically snubber circuit. These are used for different protections. Firstly, since I am studying here that over voltage protection, for this over voltage protection, the only part that we are using here is this voltage clamping device, and that's connected in parallel with that switch. This voltage clamping device is basically a non-linear resistor that is called varistor, or we can say VARI from this variable. This is derived. This word varistor is derived from this variable resistor, and it's connected across parallel across the SCR terminals. The voltage clamping device has falling resistance characteristics with increasing voltage, or we can say the resistor of varistor decreases with increase in the voltage. During the normal operation, the varistor has high resistance and draws only small leakage current. While as during the surge or when the high voltage appears across the SCR, since it's connected in parallel with the SCR, it behaves like a short circuit. That means across that parallel path, we have a low resistance, and the whole surge energy is dissipated across that virtual short circuit path, and that's connected in parallel across the SCR, and hence we are protecting the SCR from this high voltage. Moreover, for the overall protection of SCR, we are not using only varistor in parallel with the SCR for the protection of over voltage. We are using the combination of, that is the second one, that this is a snubber circuit. This basically RC and this diode in parallel with this resistor. This is basically a snubber circuit. That means for the overall protection from over voltage and high dV by dt, that means rate of rise of anode voltage, we are using the combination of, that means this voltage clamping device plus this snubber circuit. To study this later on, this snubber circuit. Overcurrent protection. Since we know that thyristors have small thermal time constant, and that means if a thyristor is subjected to a fault, short circuit, or surge, this results in the increase of junction temperature over its rated value. This increase in junction temperature, this results in the damage of SCR. Thus, to protect the SCR from such overcurrents, we are using conventional fuses and circuit breakers. The protection against such overcurrent depends on whether our supply system is weak or stiff. In weak supply system, this high current is limited by source impedance, while as in case of machine tools and excavators, we are using source as well as motor impedance is used to limit this high value of current. This fault current is it's necessary to interrupt this fault current before the SCR gets damaged, and for proper coordination, only faulty branches of the networks should be isolated. Circuit breakers have a long tripping time. That's why they are used for protection against SCR, for overloads against surge currents of long duration. While as these fast act current limiting fuse is used to protect SCR against large surge currents of very short duration. So, for protection against such overcurrents, we are using this combination of circuit breakers and this fast acting current limiting fuse. This is in series with this SCR, to whom we had to provide the protection. That means this is used for overcurrent protection. Electronic crowbar protection. An electronic crowbar is an electric circuit that's used for preventing an overvoltage condition of a power supply unit from damaging the circuits attached to the power supply. It operates by putting a short circuit or low resistance path across the output voltage. Since we know that our SER has high surge current capability, it can be used in electronic crowbar circuit for overcurrent protection of power converter. In this electronic crowbar protection, we are using an additional SER that is connected across the supply, which is known as crowbar SER. This is the basic diagram of the crowbar circuit. It consists of a crowbar SCR that is connected across the input DC terminals. Here we have current sensing resistor that detects the value of converter current. If the value of this current exceeds the preset value, the gate circuit provides signal to this the gate trigger circuit of this the gate trigger circuit provides the signal to the crowbar SCR and turns it on in few microseconds. This in the input terminals are shorted by this SCR, and hence shunts away the converter over current. Thyristor current depends upon the source voltage and its impedance. After some time, the main fuse interrupts this fault current. High di by dt protection. In order to explain this, let us consider that an SER consists of a large number of elementary SERs adjacent to each other. This means that when a gate current is applied, since this is the side gated SER, that means we have applied this gate. This is the outer P, this is the inner, and this is the inner P, and this is the outer end. That means this inner P terminal has this side gated. This gate is connected to the side of this layer, or we can say when the gate we know that SCR is turned on only when we apply the gate current. This means that if we are applying the gate current, since this is the side gated SCR, these gate charge carriers are confined to a small section only. That means we can say in this small section only, this anode, because of this gate current, anode current will flow. These anode charge carriers, or these charge carriers from anode to cathode, have to pass because of this gate current. They are confined to only this small path. That means these are charge carriers, and since the gate current is confined, that means these gate charge carriers are not they are not uniformly distributed over the whole cathode surface area. They are distributed over this only small surface area. Or we can say in this first diagram, the anode current flows only in this confined range, while as after some time the spread charge carriers, firstly they are confined to only this T1 part. Now they are confined to this T2 part. That means now the charge carriers start spreading over some part. That means up to this T2 part they start spreading. This T2 part is greater than this T1 part. And similarly we can say that anode charge carriers flow across this whole part. They are not now confined to this T1 only, they are confined to this T2 only. After some time, when the charge carriers are uniformly distributed over the whole cathode surface area, we can say that the gate charge carriers now uniformly flow over the whole surface, over the whole SCR, over all the three junctions of the SCR. That means this is the uniformly distributed, that the gate current is uniformly distributed, or we can say here the anode current is uniformly distributed over the whole cathode surface area. And this is for the whole T3 T3 part. Or we can say that this SCR turns on after some finite period of time. Firstly it's T1, then T2, and afterward when the whole cathode surface is involved, that means it turns on when the whole cathode surface, it takes some finite time for the turning on. This is and this turning on time T1, T2, T3, it depends on the spread velocity of these gate charge carriers. And this a fast rising anode current, that means the current having high di by dt, reach its steady state value quickly. which results in the high current density in the elementary SER. This high because they are confined to a small part only, that means this results in the higher I square R losses in small area, which leads to the excessive localized heating at the junction J2. Just like this means since the SCRs are turned on, these elementary SCRs are turned on over a small confined part only. This results to the localized hot spots, or we can say the localized heating at the junction J2. And this may cause the destruction of the thyristor. Thus, a thyristor needs protection against this high rate of rise of current, and a protective circuit used to protect a power semiconductor device during turn on condition is called turn on snubber circuit. This high di by dt can be avoided by improving the gate structure by incorporating amplifying gate structure, that is called a pilot SCR. This pilot SCR supplies large current to the gate of the main SCR. That means if the high amount of gate current is applied, that means high rush of, just like the pressure, that means we are creating the pressure at the gate terminal. That means high rush of gate charge carriers will be at that gate terminal, and once the gate current, and once they reach their steady state value, they will be uniformly distributed over the whole cathode surface area. Another way is by connecting an inductor in series to slow down this fast rising anode current, um, by providing the fast rising gate pulse, that is called hard gate driving, that causes a fast spread of carriers along the blocking junction J2. This whole surface of junction J2 comes into conduction quickly, and no concentration of current or hot spots are developed. We have to provide the protection for this SCR. This is the turn on snubber. That means this inductor L is used to slow down this fast rising anode current, that means to reduce the value of this di by dt. Both turn on and turn off circuits are used for protection. This turn on snubber circuit is used for protection against di by dt, and turn off snubber circuit, that is used to protect against the high dv by dt, that I'm going to teach you in the next lecture. This means both the snubber circuits turn on as well as turn off temporarily stores energy in inductors and capacitors, and usually they dissipate across the resistors. At the high frequency, these switching losses becomes more significant, and therefore energy recovery snubber circuits are therefore used to either pump back the energy into the supply, that is into the power source, or to the load. Both active and the passive snubber circuits are used for this purpose. In active snubber circuits, additional semiconductor device switching devices are used.